Here I want to talk about the trig equations. The trig equation means the equation involves the trig functions. The trig functions. Okay, and we need to determine two things. The first one is we need to solve the trig equation to determine a general formula for the solutions, for all the solutions. So this is called the general solution. The other thing we needed to do is we needed to determine the specific solutions on the interval from 0 to 2 pi. Okay, so now let's look at examples. The first example, 2 cosine theta plus 1 equals 0. So we need to solve for theta. Okay, so we calculate cosine theta equals negative 1/2. Okay, so we know that. So the first thing we needed to do is we needed to look at the reference angle for this theta. Reference angle. So the reference angle, so we should have the cos, because the reference angle is an acute angle, so cosine is always positive, right? So the reference angle, the cosine value should be equal to 1/2. So what is the angle, the reference angle should be? It should be pi over 3, right? So now we notice that this cosine theta equals negative 1/2. So negative 1/2, so cosine theta, when theta is in the second and the third quadrant, it would be negative number, right? But keep in mind, we have the reference angle, which is pi over 3. And for this theta, we have the reference angle, which is also pi over 3. So we can have, so this angle, if we let this angle to be theta 1, so theta 1 should be equal to 2 pi over 3, right? Because at its reference angle should be equal to pi, so it's 2 pi over 3. If we let this angle, the second angle, this is the theta 2, right? So theta 2 should be equal to what? Which is pi plus pi over 3. So this is 4 pi over 3. Okay, so we know that if we can find, so these two angles have the value, cosine value, negative 1/2, right? And we also know that the coterminal angles should have the same value, right? Same cosine value. So we can summarize. So that means if the terminal side is in the second quadrant and the terminal side in the third quadrant, that include all the solutions. So we can say, okay, so our theta is equal to 2 pi over 3 plus 2 pi times n, a multiple of revolution, or 4 pi over 3 plus 2 pi times n. That is the coterminal angles for the red angle, theta 2, right? So that include all the solutions. So n equals 0, plus minus 1, plus minus 2, and so on. Okay, so the next thing is, so this is the first part. This is the general solution. General solution. So we find the formula for all the solutions. The next part, we need to find the specific solution from 0 to 2 pi. So for example, for the first one, we can take n to be 0, right? So this would be 2 pi over 3. This is the one specific angles. Another one is for the second formula, we can also take n to be 0. If you take n to be other number, it will be outside the 0 to 2 pi interval. So it would be 4 pi over 3. So these are the two angles belong to the interval from 0 to 2 pi. Okay, so these are called the specific solutions on the 0 to 2 pi. So now let's look at another example. Tangent theta plus 1 equals 0. Okay, so we still solve for tangent theta. Tangent theta is equal to what? Equal to -1, right? Equal to -1, so we can find the reference angle for this one. The reference angle for this one would be pi over 4, right? And the tangent of this reference angle should be equal to 1. So it's pi over 4. So pi over 4, so we have tangent is -1, so it should be in the second and the third and the fourth quadrant, right? So it should be here and here. Right, this is reference angle for this angle, which is pi over 4, and for this terminal side, this is the reference angle, pi over 4, right? So for the first angle, so this is the theta equals, this is theta 1, which is 3 pi over 4, right? And we have theta 2. This is theta 2, which is, the plus pi over 4 would be equal to 2 pi. So it would be 7 pi over 4, right? So we can say that, we can say, okay, theta equals 3 pi over 4 plus 2 pi times n, or 7 pi over 4 plus 2 pi times n. But that is not enough. Actually, we can combine these two formulas. The reason is this one can be written as 3 pi over 4 plus 2n plus 1 times pi. And this one can be written as 3 pi over 4 plus 2n times pi. So this is the even multiple of pi, and this is the odd multiple of pi. So we can combine these two to get our theta to be 3 pi over 4 plus n times pi, right? Even number plus the odd number would be the odd numbers, right? All integers. So n equals 0 plus minus 1 plus minus 2 and so on. So this is your general solution. If you want to have some specific, the reason is, so this is the first question. The second question is we need some specific. The reason is we can put together is these two angles actually on the same line, okay? the terminal side is actually on the same line. The difference is just the pi. One of the reasons is the tangent have the period pi, right? So no matter what it is, so then the specific value solutions on the 0 to 2 pi, which is n equals 0. This is the one choice. Another one is n equals 1, so which is 7 pi over 4. So these are the two specific solution on the interval from 0 to 2 pi. So now let's make a summary. So you can see the difference between these two. Okay, for the cosine theta, the general solution have two forms, right? You cannot combine these two forms. The reason is these two lines, the terminal side, are not in the same line. And for the tangent, you can combine these two, right? You can combine these two to get us n times pi, a multiple of pi, right? So the reason is these two terminal sides are in the same line. So now let's look at the summary. First, for the equation involving the sine and the cosine, we need to find two angles in one period, right? Because the sine and cosine has the period 2 pi. So in other words, you need to find the two angles in one period. It could, in general, it would be from 0 to 2 pi. Or you can say we can choose another period, for example, from 2 pi to 4 pi. It doesn't matter, but at last, you have two angles, then you need to add a multiple of 2 pi on each angle to get the general solution. Okay, but in general, we will choose the principal period from 0 to 2 pi. Second, for tangent, actually the same thing for the cotangent, right? We need to find one angle in the period. Okay, so we know the tangent, the period is pi. So the principal period is from negative pi over 2 to pi over 2, right? But of course, you just need to choose the one which is in any period. It doesn't matter, right? So this one actually, for this problem, right? I use another color. For this problem, we have tangent theta equals -1. So we can actually choose the principal period, which is from negative pi over 2 to pi over 2. So what are the theta between negative pi over 2 to pi over 2? Which is have the -1, which is pi over 4, right? Pi over 4, then we need to add a multiple of pi plus n times pi. So that is called the general solution. General solution, right? This is another general solution, but actually they are exactly the same. So these two are exactly the same, right? There's no difference. We just have the different n, right? Here n equals 0, it would be 3 pi over 2, and here n equals 1, it will be recovered 3 pi over 2, right? So this n and this n are different, okay? But the actually they include all the solutions. So now let's look at another example. So this one would be the sine 2 theta equals 1 over square root 2. Okay, then we solve for 2 theta first. 2 theta, you cannot divide by 2 directly, okay? Because this is the input 2 theta. So 2 theta would be, so we know the reference angle would be pi over 4, right? For the 1 over square root 2. So it would be, sine would be in the first and the second quadrant because it's positive, right? So the terminal side, so this is the terminal side for the 2 theta. Okay, this is for 2 theta, not for theta. It's for 2 theta. So 1 is pi over 4, right? Plus 2 pi times n. Another one is for this terminal side would be 3 pi over 4 plus 2 pi times n. Okay, but remember, we cannot finish here because we needed to get theta, not 2 theta. So we needed to divide by 2. So we divide by 2, it would be 8 pi, 1 pi over 8 times n times pi plus, and this would be 3 pi over 8 plus pi times n. So here n could be any integers. Right. So this is the first part, the general solution. This is called the general solution. So another one is B, which is the specific solution on uh, 0 to 2 pi. Okay, so we just try the different values, right? So for this part, we can take n equals 0, so this is pi over 8. N equals 1, so this is 7 pi over 8. 9 pi over 8, sorry. And if n equals 2, then exceed 2 pi. For this part, n equals 0, so it would be 3 pi over 8. N equals 1 would be 11 pi over 8. Okay, so you have 4 general solutions. Let's look at this example. 3 cosecant square minus 4 equals 0. So we solve for cosecant square theta equals 4 over 3, right? Cosecant we know which is 1 over cosine. So actually sine square would be equal to 3 over 4. If you take the square root, so you have plus or minus, right? Square root 3 over 2. Okay, so we have 2 results. So we needed to consider different cases. Case 1, sine theta equals square root 3 over 2. Square 3 over 2, so we can find the square 3 over 2, it would be in the first and the second quadrant, right? The reference angle is square root 3 over 2, so which is pi over 3. So this is the first angle is pi over 3. Right? Pi over 3, then plus 2 pi times n, which is which include all the angles share the same terminal side, this terminal side. Another one, we need to find all the angles share the same terminal side, this terminal side, right? This terminal side, which is, so here is pi over 3. So this part would be 2 pi over 3 plus 2 pi times n. Right. So we just need to, so this time I don't want to find the specific solutions on the 0 to 2 pi. The reason is it's just easy, just try the different n values to make the angle to be from 0 to 2 pi, right? So this is the general solution for this case. Case 2, sine theta equals negative 3 over 2. Okay, so in the negative number, so the terminal side would be in the third and the fourth quadrant, right? The reference angle is what? The reference angle is still square root, sine square root 3. Sine equals square root 3 over 2, so which is pi over 3. So this part is pi over 3, and this is pi over 3. So the first thing is, for this part, you should be very familiar with the trig function values for some specific angles. Okay, so we have the first, which we have all the angles share this terminal side would be what? Would be 4 pi over 3, right? 4 pi over 3 plus 2 pi times n. So this is the theta equals. Or you have share this side. This side is actually 5 pi over 3, right? This is the 2 pi minus this pi over 3. So 5 pi over 3 plus 2 pi times n. This is, so actually this is the general solution for another case. So these 4 formulas include all the solutions for this problem, okay, for this problem. Okay, so these are for the sine and the cosine, right? These are all the examples related to sine and cosine. So we need to find 2 angles in one period, right? If you have 2 theta, right, at last you need to divide by 2, right? Three tangent square minus 1 equals 0. Okay, so we solve it. Tangent square equals 1/3. So tangent x equals square 3 over 3, right? Square 3 over 3, so we know the reference angle equals what? The reference angle, we can write this one on your scratch paper, would be pi over 6, right? Pi over 6. So plus minus, the reference angle should be pi over 6. So now let's look at the different cases, right? Case 1, tangent x equals square root 3 over 3, right? For this case, we just need to find one angle, right? So we can say x equals right, this is actually this one, right? And we have 2 angles, but these 2 angles are on the same line, right? So actually the difference is pi, right? From here to here is pi, right? This is difference is pi. So actually we can just multiply by a multiple of pi instead of multiple 2 pi, right? So this one would be pi over 6 plus pi times n, right? Because when n equals 1, it will include this term, right? N equals odd number, it will include all the angles in this terminal side. N equals an even number, it would be all the angles in this line. the terminal side would be this part. Right, so it includes everything. So this is this case, and here n is any integer, so we use this z to represent the set of all integers. Case 2, then the tangent x equals square root negative square root 3 over 3. Again, the same thing. The reference angle is still pi over 6, right? So it would be here. So this is pi over 6. So we just needed to find this angle, then plus pi times n. So x would be equal to, this angle would be 5 pi over 6 plus pi times n. Okay, pi times n. Then, we just add. So actually this is a period, a multiple of period. It's period, right? This is a multiple of its period. Okay, and for this problem, these are multiple of its period, right? These are multiple of period also, because the period is 2 pi, so the n times 2 pi would be a multiple of period. Okay, so this is so actually we have two formulas, right? One is this formula, the other one is this formula. If you want to find specific angles, you just try the different choice of n. Let's look at a more complicated one. 2 sine square theta plus sine theta equals 0. So we just solve this one like the quadratic equations, right, first. So we can factorize it. We take sine theta out. It would be 2 sine theta plus 1 equals 0. So you have two cases, right? Sine theta equals 0. Or sine theta equals what? For this part equals negative 1/2, right? So for this part, theta is equal to 0. So the reference angle is 0, right? So it's 0 plus 2 pi times n, or which is pi time plus 2 pi times n, right? So actually we can combine these two. So because this one is equal to 2n times pi, and this one would be equal to 2n plus 1 times pi, right? So we actually can combine together. You will get theta equals n times pi. Okay, this n is different from this n. Okay, for this case, theta is negative 1/2. So the reference angle is pi over 6. So you have negative, so which is in the third and fourth, right? So this is pi over 6. So this one would be 7 pi over 6 plus 2 pi times n. And another one is for this one, this is the 11 pi over 6 plus 2 pi n. This is pi over 6. Okay. So if you want to find the specific angles in 0 to 2 pi, that would be, for this case, we can take n to be 0, which is 0, n equals 1, so which is pi, n equals 2, which is outside the 2 pi. This 2 pi here, we use the parentheses. That means 2 pi is not included. And for this one, we can take n equals 0, which is 7 pi over 6. If n equals 1, it's outside 2 pi. For this case, we have 11 pi, n equals 0, and so that are the specific angles. So next one, we have negative 3 sine x plus 3 equals 2 cosine square x. So we solve for this one, but we have sine and cosine, right? So we need to convert one in terms of the other one first to have a single sine or single cosine. But here we notice that it's convenient to convert this one, right? Because we know this is equal to 1 minus sine squared. So everything is about sine. So we expand and simplify. It will be, I skipped some steps, sine 2 sine squared minus 3 sine x plus 1 equals 0. So we factorize it. Sine 2 sine minus 1 times sine x minus 1 equals 0. So we have two solutions, sine x equals 1/2 or sine x equals what? Equals 1. Okay, so you have so for this one, we have the reference angle would be pi over 6, right? Pi over 6. So this one would be pi over 6 plus 2 pi n, because this is in the first quadrant. In the second quadrant, right, it would be 5 pi over 6 plus 2 pi n. So this is the general solution for this part. And we have the general solution for this part, which is whose value equals, we only have one angle, right, which is the positive y-axis, sine equals 1, right? So it would be pi over 2, but the terminal side is only on here, right? So this tells you that you only have one formula for this branch. So this is pi over 2 plus, it's 2 pi times n. Okay, so that are all the solutions. Then if you want to find specific solution, you just choose the different choice of n. Another one is 4 tangent squared x plus 5 tangent x minus 6 equals 0. So the same thing, we can treat this one as a quadratic equation, and so it would be 4 tangent x minus 3 times tangent x plus 2 equals 0. Okay, so we have tangent x equals 3 over 4, and tangent x equals negative 2. Okay, so here is, if we want, we can find one angle. So for the tangent, we just need to find one angle, then plus a multiple of its period pi, right, to get the general solution. But these are not special numbers, right? We have no special. However, we have learned inverse trig functions, right? It tells you that there is an angle which is called arctangent of 3 over 4. Arctangent of 3 over 4, which is in the first quadrant, right? So this is the first quadrant. So this angle is here, right? This is the arctangent 3 over 4. Okay, so this is this angle and the reference angle, right? Actually, so we can have x is equal to arctangent 3 over 4 plus n times pi, which is this side and this side, right? So you include everything for this part, And for this part, we know we have arctangent of -2. This is the angle. Arctangent is an angle, right? Which is in the fourth quadrant. Okay. So this angle has the terminal side, which is here. So if you need to include all the points on the same line, including this part and this part, so actually x is equal to arctangent over -2 plus pi times n. In this example, if you have sine theta equals 3/4, right? 3/4. But we don't know. This is not a special number, right? But it's positive. It's positive, so we know it should be here and here, right? Here and here. So how to get this? So you have twos, right? So how to get this, the solution, the general solution? The first thing we still need to do, we still need to look at the arc sine 3/4. We know arc sine is from -pi/2 to pi/2, right? Arc sine is from -pi/2 to pi/2, but this is positive number, right? So it must be this angle. So this is the arc sine 3/4. Okay. So arc sine, the range of arc sine is from -pi/2 to pi. This you should be careful. The arctangent is also from -pi/2 to pi/2. Arc cosine is from 0 to pi. Okay. So this is this one. This is no problem. We just need to have one solution, which is the arc sine 3/4 plus pi 2 pi times n, right? This is no problem. This is no problem. So what about this terminal side? This term, so we notice that this angle should be equal to this angle, right? So this angle should also be, because they should have the same reference angle. This is arc sine 3/4, right? Arc sine 3/4. So this is this angle. So what about this one? Can we find an angle? So this is another one, which is, or theta equals what? This part, which is, so this angle, we need to find this angle, right? This angle is pi minus arc sine 3/4. This is this angle. Then you need to plus 2 pi n, right? Then you can simplify it. Okay, so this is this problem. If we look at this problem, if you have cosine theta equals -1/3, okay, again, this is not a special angle. So the first thing is we still look at the arc cosine of 1/3. Arc cosine of 1/3. Okay, so we know we have this one, right? This angle and cosine should be negative, so the terminal side should be in the second and the fourth quadrant, right? Arc cosine -1/3, that is an angle between 0 and pi, right? It's not a reference angle first. So arc cosine 1/3, which is actually this angle, right? This is arc cosine -1/3. arc cosine negative 1. So we have one solution, which is arc cosine negative 1/3, right? Negative 1/3 plus 2 pi times n. Okay, so the next thing is, what is this angle? What is this angle, right? What is this angle? In other words, we need to find the angle with this terminal side, right? With this terminal side. So the idea is you just need to find the angle with this terminal side, then multiply by, add by a multiple of 2 pi, right? Then you get all the terminal angles for this one, right? Since arc cosine negative 1/3, which is actually this side, right? Which is for the terminal side for this side. So you just add a pi, 2 pi times n, then you have all the angles share this terminal side. So now our question is this side. Okay, so another thing is, the idea is, let's look at this terminal angle. It's not easy, right? It's not easy. But we look at this part. This angle also have the same terminal side, right? So this would be the theta equals what? So this side is actually the opposite of this angle, right? The opposite of this angle, so which is negative arc cosine of negative 1/3 plus 2 pi times n. This is another one, right? Okay, or we actually the representation for the general solution is not unique, right? The idea is you need to find all the coterminal angles, right? If you like this one, let's use another way, okay? We use another way. We can have the different cases, still the second one, right? Still look at the second one, right, more clearly. So you have this one and this one, right? This is the coterminal angle. So this is the arc cosine of negative 1/3, right? So that means cosine of this angle equals negative 1/3. So its reference angle, this angle should be what? This angle should be, they should have the same cosine value, the absolute value cosine value, so it should be equal to 1/3, right? This angle should be, the value cosine value should be 1/3, so this is the arc cosine 1/3. Okay, so this angle is also arc cosine 1/3. Okay, so our aim is to find this angle. So this angle should be pi plus arc cosine 1/3, then plus 2 pi times n. Okay, so actually these two formulas represent the same coterminal angles, although they have the different representation.